don't know about you guys, my head is still spinning from that keynote, so we'll try to change pace a little bit here. So first to introduce myself, my name is Daniel Stark. I'm a field applications engineer with NI. So I work directly with customers, making sure that they're getting up to speed on our hardware and software platforms. I live in St. Louis, so not too far away. And I've been a test engineer for about 10 years now. And I've been involved in large-scale application development, hardware implementation, integration, on all manner of products. So I've spent a long time working with Actor Framework, which we're going to focus on today, but I've also worked in other languages outside of LabVIEW. So today we're here to talk about this problem.
I'm in there. Surprise. So thanks.
Yeah. If you've worked in LabVIEW for more than a couple weeks, this should probably look familiar to you, right? This is what code starts to look like when you started off your project. Not really sure what you were going to do. You start adding a function here and there. You start to build it up a little bit. And then a couple months, couple years later, you notice this is what your application looks like. And this is not sustainable at all.
Oh, but we'll keep doing it.
So, what was that?
Keep doing it over and over. Keep your use again.
Well, I guess the problem becomes when you need to scale it, right? When you need to start getting to the point where you're working with a bigger application, multiple teams, multiple modules that need to be able to talk to each other, right? You're going back and adding a test point, and now you have to update 75 places in the code to make sure that test point makes it from your instrument into your database. That's not really sustainable. Right? And we tend to think right at the beginning of a project that I'll just start to work on it, and if I take all this time at the beginning, spending time working on this project without any output, it's not going to be valuable. But again, what we find is that if you put in that time up front, right, the time you spend later is a lot more valuable, right? As opposed to if you don't put in that work up front, you're going to end up spending a lot more time later, making sure that your code works. So one thing I want to touch on before we jump into this even further is, I know we were talking downstairs about AI, right? As AI starts to write more and more of our code, even within our platform, it's starting to take over a lot of our workflows. So it would be right to ask the question, why is it important to understand advanced architectures in LabVIEW if AI is going to be able to write it for me? And I think as much as we're starting to lean on AI to do our code, I think one of the areas we're seeing that AI starts to fall short is when you have a large, complex application, multiple moving pieces, synchronization, and most importantly, talking to the real world, hardware communication. Right? Most of AI is optimized on the use case where software is talking to software, right? Web interfaces, databases, logs, all that kind of stuff. When you start to get to the point where you're working with hardware and things need to be synchronized, your data needs to come in at certain speeds and move certain places, we're not finding that AI is quite there yet. And I would think that even if AI is going to get there, it's going to have to start using frameworks like this one to start working. So we're still going to need to understand these even when we get there. But we're not even there yet. Right, so the types of things that you run into when you're working with hardware, right? You have multiple independent device interactions, right? You're going to need different hardware that might be blocking each other when you're working with the operating system. The most important thing from a user interface perspective is that everything needs to remain responsive, right? The computer can't just run off talking to hardware without checking back for user input, for most importantly for like emergency stopping and things like that, but you want to make sure that the UI is preserved, right? Determinism can be really important, especially in your real-time applications. So AI is not quite here to take this level of programming away. So I guess we'll start with this. By a show of hands, who here is familiar with the queued message handler framework inside of LabVIEW? Okay. Who here has worked with object-oriented programming before? Okay, wow. That was not the number I was expecting. And one more. Who here has actually worked with Actor Framework before? Okay. I saw more people going like this than actually raising their hands. So no, that's good. So the goal today is to try to work from a standard LabVIEW architecture, the queued message handler, and to understand how we can turn that step by step into an actor so we can understand what an actor is. And through that, we'll understand how it works and how to use it. So we're going to go step by step to do that. So to start with, we're going to review some of the basics for queued message handlers and a little bit of object-oriented programming just to get the very basic concepts we're going to need to make that transition. So the first thing we're going to look at is a queued message handler. Right, so this is one of the introductory LabVIEW architectures. We have two independent loops, so they can run in parallel. The top one is going to handle your user input, and the bottom one is going to handle your actions. They communicate with each other through a queue. In this case, we have a string, which is going to represent what action we need the handler loop to take, and a variant, which is going to handle any data that we need to pass between the top and the bottom loop. This is one of the first architectures that you'll run into when using LabVIEW. I'd like to spend more time on it. I'm hoping that we have a strong background on this because this is what we're going to use to move forward. So I guess any questions about the queued message handler or anything that we should cover quickly before we go any further? If you have a question, if you could step up to the microphone, there's apparently a recording going, so they want to make sure that everything's heard on the recording. Yeah.
Sorry, probably a dumb question, but is there any difference between QMH and producer-consumer loop?
And the what?
Producer-consumer loop?
The difference in the QMH, there isn't much of a difference for the purposes of this. Yeah, for the purposes of this discussion, it's the same basic idea.
Thank you.
Yep. Yeah, so if you're familiar with the producer-consumer pattern, this is another element, another aspect of that. So another thing that we want to be aware of is an object-oriented concept called encapsulation. So as we move in our programming experience from just running a function, putting a little bit of data in and out of a VI, we start passing data back and forth. Encapsulation becomes much more important. So LabVIEW classes, which are an object-oriented concept, it seems like most people in here are familiar with that. They're built on the LabVIEW, on the cluster type, which is, again, in LabVIEW, it's a very easy comparison because a cluster is basically just a grouping of data. So the LabVIEW class wire is essentially just a special cluster in LabVIEW. And what it pushes you to do is it pushes you to take all the data that your code is going to need and keep it in one place. So that's going to be an important concept that we're gonna need. And one other concept in object-oriented programming that we're going to need is the concept of inheritance. So if you have, when you're building a class-based architecture, the value of inheritance is that you can basically create the same structure in multiple different classes to perform different behaviors. Now, that was a lot of words. Try that again. If you're going to be performing the same action in multiple parts of your code, and in each time it's going to be slightly different. So a quick example would be an instrument. You have your DMM and you have your oscilloscope in your same system. Each of them is going to need to initialize, measure, and close at a certain point, right? So you want a way to set up your code so that those are done in a standard way. So you don't have to continuously repeat. And the rest of your code doesn't have to worry about what's going on inside those boxes. So what you can do is you can create what here would be an instrument class, which has those VIs. And then inside your code, you implement that class in different forms. So you have your DMM and your oscilloscope. And when that VI is called, it'll decide what to do based on the class wire that you're passing into it. So this is a way to start to scale applications just from an object-oriented end. So those are the three concepts we're going to be working with to keep track of. And from there, we're going to take a QMH, a queued message handler, and we're going to turn it into an actor live here. So in order to do that, I'm going to give you the preview of what it takes to turn a QMH into an actor, right? And we kind of just discussed it. In a QMH, we have our data that needs to be passed around our handler loop, and we're going to turn that data into a cluster and turn it into a class so that we're, instead of passing data back through the shift registers in our handling loop, we're gonna have a class passed around. And instead of the case structure that we have in our queued message handler, we are going to use a class to decide what action to take inside that handler loop. So all of that is very theoretical. Let's actually open up an application and I can show you what I'm talking about. Okay, one when I'm keeping LabVIEW code open, I'm going to try to zoom in so you can see things because I'm looking at my screen over here. Please let me know if you can't see it. That's important because I'm going to be looking down here. The second thing is this should be interactive. I'm going to try to explain each of the parts of the code that I'm looking at. If you have a question, please raise your hand, let me know, and jump in. We're going to try to do this interactively if possible. So the application that I built to demonstrate this concept is my LabVIEW Tamagotchi. All right, this is the code or programmer personified. All right, so if I run it, as it ages, it starts to get hungry, starts to lose energy, starts to get a little dirty, and I can feed it to decrease hunger, clean it to increase cleanliness, sleep to get energy, and of course, if I get a broken run arrow, it gets angry. All right, if I fix a bug, it gets happy, and if it eats any spaghetti code, it does not do well. So this is a very simple LabVIEW application, and it's built in that QMH structure that we were talking about before. So you can see here the top loop is just taking in all the inputs of all the buttons, and it's sending the state, which in this case is just the string. I'm using that same data type to pass a string from the top loop and dequeuing it in the bottom loop. And that's telling the handler loop what to actually do, right? Increase or decreasing parameters, setting the, here, I should zoom in already, right? So down here, we're showing what the UI should be putting out. So far, so good? Okay, so the first thing we're gonna do in our journey to turn this into an actor is we're gonna take all this data that we're passing through shift registers, right? This is the data that needs to be preserved on each iteration of the bottom loop so we can keep track of the state of the system. We're gonna push that into a cluster. And instead of doing that live on stage, I've already done that here, so you can kind of see what that looks like. Before I continue, I just wanted to let you guys know, this is gonna be available on the slides, and this code is available for download on GitHub. So if you wanna review this later, you will be able to. I have a QR code later, and these presentations will be posted online, so the links will be available as well. So this is the exact same VI with all the same data, but we've already started to make it look a little cleaner by pushing everything into a cluster. And if we need to add any data later to this loop to keep track of state, adding it to a cluster is going to be much easier than wiring another wire through our loop on the bottom and trying to figure out where we need it. Right, so this is now running with our cluster, and you can see it's the exact same code. It's not running any differently. All right, as one more step, just while we stay inside the QMH, what we can do even further if we want to make this even cleaner is instead of writing all the code inside each of these cases, we can just turn each of these cases into a VI. So inside of these VIs is the exact same code we were running before. Right, so I haven't done anything to the code here at all. All I did was create sub-VIs to make sure that everything is encapsulated. If you've ever worked with an object-oriented programming, an object-oriented program before, this will start to look a little bit like a class, which is on purpose. Right, each of these VIs is doing the same thing to the same cluster over and over again. And again, this still runs just fine. So I haven't changed anything yet. Again, any questions about what we've done so far?
What does that icon that you got does actually? Not this one. So yeah, that small box there.
This?
Yeah.
So inside of each of these VIs is the same code that was running in the case structures before. It's basically just updating the values that we need to update. So in the case, this is the cleanliness case. So what it's doing is when I press the clean button, it's sending that clean case down here, which sends us into this case to actually call this VI. And it's updating the cleanliness value by 20. So you'll see here.
Not use any property node here?
No, there's no property nodes here. This is all just clusters. These are all clusters. We haven't done anything outside of, this is all possible to do within a QMH. We have no actors visible yet. This is just getting us to the point where we can easily turn this into something that we can call an actor. So the next step is where we're going to make the jump to actually turning this into an actor that we can actually refer to as an actor. To do that, again, it's actually a couple more extra steps. I'll show you what the changes are, but I built another version of this so you can see quickly what it looks like. So this is the same application, still runs exactly the same way as before. Everything still works. But inside we've made a couple of important changes. I can see if I can get them side by side here so you can actually compare them. So here's important change number one. The first thing we did is I changed the data type that's being passed from the top queue to the bottom queue. So in our QMH version, we were just taking a cluster and we were sending that cluster down with a string to tell the bottom loop what case to run. And whereas in my new actor-based version, what I'm taking in to my cluster is now a class. And we're going to describe why we're doing that in a second. But this class is going to contain the information that the handler loop is going to need to perform the action. So that's one important difference. The second important difference now is instead of a cluster on the bottom, I apologize. Apparently they're renovating a bathroom next door. So I'll have to show them my vomiting and Tamagotchi GIF. So instead of our cluster going into our loop, we now have a class on this side. This is a different class. So this class is going to actually be our actor class. This is the data that we're going to need to actually perform the work that needs to get done. And the final thing that we've changed down here is we now no longer have a case structure. What we have is just one VI. And this VI is just called action. So we talked before about inheritance, where a VI can behave differently based on the class that's being passed into that VI. And that's exactly what we're doing here. We're passing a class into the queue. It's coming out down here and going into this message. And if I click on that, you'll actually see that. These are all the different behaviors that this VI has now, depending on which class is passed into that VI. And it's all the same behaviors we saw before. We haven't changed anything here, right? I can go into, we were looking at the clean before. So the actor is what's containing the data. That's our cluster that we had before, our cluster of data. And we're just modifying it with the action message inside of our clean message class. Yes.
Is that a property node?
So this is it's a kind of property node. It's a specific to classes. When you access class data, classes do something called data protection, where depending on the level that the data lives, you either can or can't access it, and you can create special property nodes to access that. Because of the way that I'm implementing actor framework here, this isn't the actor framework that NI puts out. This is a very simplified version just to show the concepts. So in order for me to access the data inside the class, I need these special property nodes to do it. I'm going to show you a real actor framework version of this in a minute that doesn't require that. So this is just an artifact of the way that I built this to show how this works.
You got a question here.
Oh, sorry. Go ahead. Actually, and I just remembered, if you can step up to the microphone when you ask a question, just so we have it for the recording. I apologize. I forgot when you raised your hand. I don't mean to discourage questions. I know walking up to a mic is not fun.
Yeah, I was just going to ask, so when you have the VI that has multiple different implementations, is that similar to like overriding a function in like a text-based language?
That's exactly it, yes. So in this case, I created something called a message class, and that message class has one action, and that action is blank, because I'm going to override it, and that's exactly what I did. I created all those classes underneath it and overrode that specific action. Yeah, good question. Okay, so we haven't changed that much, but we're now looking at an actor. This is the basics of what an actor is. And I just want to repeat what we've changed here. The things that we've changed are we've started passing a class down to our message handler instead of passing a string down. And we've encapsulated our data in a class on the bottom loop. This is what we mean when we say we're working with an actor. Now, can everyone still hear me over that noise? Okay. I'll try to talk a little louder. Let's see if I can get this a little closer. Oh my goodness. Wow. Look at the draw here on rooms. Okay. So the question now becomes, if we really didn't change that much, why would we do this? What value do I get out of making these slight changes to the way that I write my code? Right? Obviously, it's a little cleaner. Actually, there's a slight disadvantage in that I now have to create a new class for every time I want to send a message instead of just putting a string down and adding a case here. All right, so if anything, I may have added even a little complexity. So for that, I'm going to jump into what the NI actor framework looks like. Some of the VIs are a little more complicated, but I'll show you where all these pieces are that we've discussed inside the actual NI actor framework so we don't lose our bearing. So for that, I built yet a third version of this. One of the things that is important about actors is you can't just run the VI, you have to actually launch them. There's a couple of steps you have to get set up. Actually, they're not even that interesting. You really just take your actor and launch it. So, but this is going to be our same actor as before, right? Still gets sick when it eats spaghetti code. And just to prove the point that we haven't done much to this, this is our VI, and this is what it looks like. So I'm going to put that side by side against I'll put it against the class version that we had before. So we'll see a couple of differences here, but they're really just differences in how things are packaged. They're really not that different. So here's my actor class over here, right? Which compares to my actor class over here, right? Here's my message sending, which compares to how I'm sending messages over here. Now, there's a nice packaged VI that's actually sending that message, but if I look inside it, I can see I'm sending a message on, this is called message enqueuer. So it's just a message queue. And this is going to be a little more involved, but inside of my handler loop is ultimately the same thing that's happening here. It's just an action and some error handling. So this is the NI actor framework. It's called actor core. This is the handler loop for an actor. And it looks like there's a lot going on, but this VI here, this is our DQ. It's taking a queue and dequeuing a class, and it's sending that class into a VI called receive message. And inside that receive is a VI called do. So in this case, in the actor framework, the VI is called do as opposed to action in the version that I made, but it's doing the exact same thing. It looks pretty similar. It's the same VI we created before, which is just receiving a class to decide what to do inside of that case. So it's replacing our case structure. Any questions on that jump? Yes, please, if you don't mind stepping up to the mic.
So since you're moving the entire case structure into a separate event handler, if I want that case to update a front panel element, do I have to pass a ton of front panel references into that?
That is a fantastic catch. That's exactly what you have to do.
So there's like no way around that.
There is not. No. Right. So yeah, it's a good question. You do have certain things that you'll have to do inside of an actor that are not going to be like a normal VI, but the benefits that you're going to get from it are going to outweigh. So let's talk a little bit about some of the benefits that you start to get when you're building an actor. So one thing that should become a little bit clear is that, well, I'll back up a second. The reason why we build actors is because we're going to have a system that needs a lot of different pieces that are all running concurrently. So this is a quick way to build an actor, which is essentially one loop that's running, doing its own thing, and I can spin up as many actors as I want in a system. Those actors can be the same type, so I can have multiple instances of the same loop, or they can be different types and they'll need to communicate with each other. What becomes important when you're doing that then is that actors are going to need to communicate with each other. That's the important part of a big application with concurrency. And keeping track of these queues becomes a really big part of what your application is going to look like. That's what, when you develop an architecture, right? What we're talking about today is a framework. Actor framework is a high-level way to build an application. An architecture is going to be how you decide to use this and build an application. And it's going to be the scale, the way that you use, the way that you actually put this into your application. So keeping track of those queues so that actors can communicate with each other is not a trivial part of the way that you build your application. One of the things that comes built in to Actor Framework is that actors can launch each other, and when they launch each other, they can keep track of those queues themselves. And you can build up an entire chain of actors that are dependent on each other, and they all open and close together, and they can communicate with each other. So I can show you kind of what that looks like in here, so you get an idea of the types of things that you can do with Actor Framework. So again, I'm going to launch my, where'd it go? I'm going to launch my actor. And off of this actor, I want to simulate a hardware interface. So I have another actor that I built that's going to very simply just provide buttons for a user to input. That's going to pass a message over to this VI to perform these same actions. So this would be my software simulation code, and this could be something that's reading hardware. In this case, it's just a software module, but it's a separate piece. And if I press the buttons here, you can see it's performing the same actions that the buttons on here would. So this actor is what's launching this actor interface. And if I stop my actor, it stops everything below it. So it means that this top level actor now becomes the parent of all the actors below it. And I'll add, if I look inside, this is my hardware interface actor. I'm accessing the queue of the parent actor. The VI here is called recaller and queuer because my Tamagotchi launched my hardware component. My hardware component has access to the queue of what's called the parent actor that called it, and that's how it's sending it the hardware messages. So in this case, I'm just pressing buttons, but I could equivalently be reading hardware here and sending those messages back to the top level interface. Ooh, my Tamagotchi is very sad. Okay. But that's just one actor talking to one actor. All right, once I build this into an actor, I can start launching these at any number that I want to. And it doesn't have to be decided while you're programming. It can be decided later. So in order to demonstrate that, that is not working. Oh boy. Oh, I locked myself out. I'm gonna have to restart that. I apologize. Yay, I get the first live demo failure of the day for you guys. Let's try that again. Okay, so what this button is doing here is it's just launching that Tamagotchi actor. But I can do that multiple times. There's nothing stopping me from doing that. I haven't coded any extra actors here. Each one is running independently. And each one of these can launch its own hardware interface. And because each one is keeping track of its own parent, each one will interact with the actor that launched it. And each one will also close with the actor that launched it. Any questions on any of that so far? Yeah, if you mind stepping up to the mic, please.
Yeah, so this is sort of a follow-on from the previous question. Like looking at all of that, and what I've been trying to figure out in my head for a while now, and using the actor framework and actors together to build a larger application is, well, let's say my root actor is responsible for all the UI. It does all the front panel indicators, controls, and stuff. Like, I just want to run this idea by you. Like, could I, instead of doing the front panel references, instead have messages that the nested actors can send to the root actor to update, to like send it data so that it can update the front panel indicators? Like, whatever the little dude, he's feeling dirty. He sends a message to the UI actor saying, here's my dirtiness level or cleanliness level, and then the root actor updates that on the front panel.
Yeah, so that's actually exactly how you would do that. As you start building a larger application, you probably want to have an actor that's responsible for the UI, and I might argue that you probably don't even want that to be your root actor.
Oh, I mean, it may not be.
It could be any of them. Yeah,
so
but that's one of the things that you want to make sure is running concurrently to the rest of your application. This is how you create an application where the UI is never going to lock.
Okay.
Because the UI is controlling its own data, and it's just waiting for messages from other parts of the application. Now you still have to think about coordinating with those other pieces, right? If you need to be able to quickly stop the hardware and the UI works, but the hardware is locked, you still have to worry about that. But you never have to worry that the button won't click.
Okay, yeah.
At that level.
Yeah. So I don't want to hog up the whole time, but I got more questions.
Yeah, go for it.
Okay. The other question then is like on the issue of hardware locking and things, like a common problem is I want to start my test software and no one plugged in the RTD. No one plugged in the oscilloscope or something else. What would be your recommendation for handling errors like that when you try to launch the hardware actor or the hardware interface and it can't go?
I guess, well, maybe let me ask, what are you doing now? Is it just failing silently?
No. Well, right now I'm not using the actor framework for my application. I have like a big error queue, and I just pass the error queue into every single loop in the whole application, and it just logs that, and it goes to the little thing. Okay. So Actor Framework does have a lot more than I was describing here. I was trying to give you guys an idea of what an actor is and the very basic idea of launching them. Actor Framework is quite large. Let me see if I have it here in a way that I can show you. There it is. So where is the actor class? Many of these VIs are available for being overridden, and one of them is handle error, right there. So error handling is, again, it's not a trivial part of any application and figuring out where those errors are going to go. But having some sort of error handling is built into the concept of an actor, and that's going to be that right inside of my queued message handler, there's the handle error VI that goes at the end of the loop, and that's exactly where it is inside the actor as well. And you can override that to identify the behavior. A quick note for anyone that's worked with this before, or are you planning on working it in the future, Actor Framework actually uses a specific error number to stop. So if you accidentally pass that error along from something else, you can accidentally crash your application if you're not careful. I do not know why that decision was made. It was made a while ago by, I think, the guy who designed this. But yeah, just something to be aware of. Does that answer your question? I think it gives me something to work on then.
Okay.
Okay, thank you.
Yeah, there was another question over here. Yeah.
So are actors like clonable by default? Because when I see you click that button, I use DQMH a lot. So I'm thinking of like a clonable module versus a non-clonable module. So clicking that button, actors are inherently clonable?
Yes. So there is really no such thing as a non-clonable actor.
Okay.
That's really the way you can think about it.
Great.
Yeah. And
Thank you.
if you're used to using DQMH, like a lot of the higher level concepts should seem pretty familiar here. There's just a slightly different implementation. I think DQMH officially is an actor type framework.
Yeah, but you don't have to know the guts of it. To use
Right,
it.
exactly.
Yeah.
Well, until something breaks.
Yeah, well, hasn't happened for me yet.
Which is true of pretty much all of these frameworks, right? This is how they look when they work, and you kind of need to understand a little bit about what's under the hood when things go wrong. And that's kind of what we're focusing on here, is what's actually going on inside an actor. Okay, yeah, thank you for your question. Okay, so just to review kind of what we did here. All right, we took our QMH, our queued message handler, and moved everything into a cluster. And this is the proof that I actually moved all of those manually. Right, and then we took each of those cases and turned them into their own standalone VIs, which is how it started to look like a class in our message handler. And then from there, we jumped to a very basic actor implementation by changing our message loop, our message queue, from sending clusters to sending classes, right? But ultimately, we're still sending a message. And in our handler loop, we're changing our cluster to a class. And we're changing our case structure into a dynamic dispatch VI call. That's it. that's I would say that's the scary thing that everyone's worried about learning about. So that's really all it takes to understand. So now's a good time for questions, then we can close.
It's a pretty basic question, though. I see what you went from cluster to class. Can you just create the class as like if someone's never seen you do that before?
I missed the last word of that question.
Could you just create the class?
So I did just create a class, but that's actually a good point that I didn't quite cover. Actor Framework, as it's implemented in LabVIEW, comes with a lot of scripting tools. So when you're creating an actor, you don't actually create just a class and create all that inheritance and do any of that. You go into, I believe it's on the project, and there's an actor type right there. And that actor will give you all this functionality. It gives you all the VIs that you can override. And when you create VIs inside that actor, there's another button to allow you to create a message. So inside of the actor, because remember, every message now needs to be its own class. And that class needs to have the ability to call it from inside of a loop and all of that stuff. So if I go into an actor, those actions that actor can take, there's an option to click on them, and there's an actor framework dropdown. And I can create a message right there. So all of that work that I did manually, basically, in this application can all be scripted. And you should not be building that from classes yourself. All right, next question.
Would you mind showing your block diagram with the actor and showing those references to your front panel controls?
Yes.
The individual references?
That one?
Yeah, so I was curious if you had made a cluster, and then I think, could you not get an array of those references and make that your cluster a type def into your actor where it says actor in? Could you make that a type def based off a cluster and then feed in reference to all the clusters? That way you don't have to, every time you add a new control, you don't have to add a...
Yeah, so in this case, I was just using the same controls that I had from the other VIs. This is a type def cluster, but I think what you're saying is if I made my front panel into a cluster and then just reference the cluster, you could absolutely do that. There's no reason why you couldn't. I think when dealing with clusters and types, you're still going to have to keep track of what type each reference is, so it gets just a little hairy. But yeah, there's no reason why you couldn't do that. Go ahead.
So I'm still just a basic LabVIEW user, so this is probably below a lot of people in here.
No, go for it.
But I have a bench, and I have about a half a dozen power supplies, electronic load, thermal stream. And so I like to make a GUI, or I have a GUI that uses just a while loop and a case structure and an event structure. And I think we just call it a state machine. I don't know if that's technically what it is. And it works pretty well, but it's kind of slow, like, because while we're not pushing any of the buttons of the interface, it goes out and queries one instrument and then queries the next one, then queries the next one. So the actual updating of the front panel elements is a little bit slow. Is this something that I would get benefit from if I dug in to learn how to do this?
So I will say, if you're just starting out with LabVIEW, this is probably not the first thing you want to do. There are a lot of pieces here. I think what you'd probably start with is you'd probably go back to this QMH version that we've been talking about before, and that's designed exactly to do what you're talking about.
Okay.
What you're doing is you're separating your user interface and your top loop from the actual actions in the bottom loop. Do I have the better picture of it over here? Yeah.
Would that actually then query the instruments in parallel and not have like visa hangups?
Correct. So that your top loop is what's handling your UI elements, and that doesn't lock up based on instrument behavior. Instrument behavior would happen in another loop.
Okay.
So,
Perfect. That's what I was looking for. Thank you.
Right.
So I have a question regarding the memory. So does all the classes come into memory when we run the application? Like, can we establish the factory pattern here somehow?
That is a good question. Let me just make sure I'm understanding your question. You're asking if you have a big application with multiple different actor types or class types, if there's a way to only load certain ones in to your build. I believe there is a way to do that, but I'm not sure off the top of my head. If you come up to me afterwards, if that's important to you, I want to discuss it more because I'm curious what the use case is and I want to figure it out for you.
Yeah, sure. Thank you.
So every message in Actor Framework is a class. And are those classes defined in the same way that you define them in regular LabVIEW object-oriented programming? Like, is there any difference between an actor class and a regular class in LabVIEW?
So the difference, there's no difference in the inherent structure. They are all just classes, and Actor Framework is built in LabVIEW. So the LabVIEW Actor Framework is all built on top of LabVIEW classes. Those classes, though, inside of Actor Framework are inheriting from other classes. There's a fairly complicated structure of layered inheriting classes that you're already starting with when you build that. So the message class inherits a couple layers and the actor class inherits a couple layers also. So it's not just something you can just drop your own class on and build. You're getting all the extended behavior of the higher level classes when you create those.
Can you show us where you define a new message class?
So you don't actually go into Actor Framework code to find the message. In order to create a message, you pick an action that your actor can do. So in this case, when you build an actual actor, those VIs live inside the actor, which is how they're able to access the data. I forget, someone was asking the question before about the property nodes. This is what this code ends up looking like inside the actor itself. Right? There's no need for property nodes because this is my cluster that's being passed back and forth. So this is an action that an actor can take. And then when I right click on that, I get that Actor Framework dropdown. And there's a create message class, create message button. And this scripts the entire message creation for you. That class gets created with its proper inheritance. There's the option here to create child of abstract message. If you want to extend the message capabilities, there are ways and reasons why you might want to do that, where you can add more capability to what a message can do. You can build your own message type inherited from the message class and then have all your messages in your application inherit from that as well. But you shouldn't be ever needing to interact with the actual message class, the abstract class inside the actor.
Okay, thank you very much.
So, like I said, this is completely new. So I'm really interested in what's the learning curve and what are the learning tools. If you wanted to learn this from the ground up, do you have a recommendation? And do you expect like a month, weeks, multiple months to be proficient?
Yeah, I'll let you know when I'm proficient and I'll get back to you. Yeah, I'm trying to remember if we have any courses online. In general, there's a lot of material online for Actor Framework. There's a lot of open source stuff. I think I have some links coming up. I'm going to close out with a couple more slides, and there'll be some links there. I think there is no replacement for getting your hands dirty and building this and seeing where it breaks. That's really when you learn things. I think my motto at this point is, when it breaks, I'm going to learn something. That's how this works. It takes a few months of working with this to wrap your head around exactly what's going on. I would not take this on as I have something due next week. Let me just use an actor for it. So that answer your question? Kind of? Okay, great. There's a line over there. Sorry. No, you're fine. You're fine. Sorry, I was pointing there. Yeah, go for it. Yeah.
The encapsulated version of your QMH is
Yeah.
pretty easy to troubleshoot. You can put retain wire values on. You can see where each state is. You could even track the previous states. How do you troubleshoot with the active framework? How do you know
that?
Because there's a whole bunch of different things you got to turn on.
Who said that? Yes,
you put breakpoints all over the place and it's stopping everywhere.
So you're pointing out again something that's not trivial is then keeping track of the data. This is what starts to become the issue when you're working with actor framework is, where is my data actually going? The first thing to realize is that the actor core, which is the UI that we're showing here, is a reentrant. It's a cloned reentrant VI. So it's basically popping up in memory. And if you were to put a breakpoint on it, it's going to breakpoint the instance that pops up there. So you can still breakpoint it, but you got to kind of catch it early and then turn on retain wire values right at the beginning so you can catch it. It's also not trivial to keep track of all the actors that are potentially launched. Many of the actors that you're going to launch in your system are not visible. They're talking to hardware on the side, they're talking to a database, and keeping track of what actors are running is also an important thing. That's something you want to keep track of in your architecture, is how am I going to know what actors are running? There are some good open source tools for doing stuff like that. I believe it's been a while since I've used it, but I believe MGI has some good VIPM packages for doing things like managing actors. There's one that I remember that when you're writing the code in development, it'll pop up a window that'll show you the list of all the actors. So as long as you're using that plugin, you can see all the actors that are running, you can pause them, you can stop them if you've lost track of where that queue is in your code and things like that. But so the short answer is, it is not as easy. It is still doable, but it is not trivial.
Yeah, I find it's very difficult. Let's say somebody gives you an actor. How would you determine how it works or how to implement it?
Yeah, so an actor is really a self-contained module. So when you open up an actor, the most important thing about the actor is going to be what VIs are inside of it and what are those doing. That's going to be the very first thing you want to do. And that's the basic function of what that actor is. What's going to control when it does those actions is what messages get sent to it. And that's going to be much more dependent on the architecture. An actor can send messages to itself, but more likely it's going to get messages from the rest of your application. And in this example, I'm showing each actor keeping track directly of other actors' queues. That can get a little dirty pretty quickly. But that's part of what your architecture is going to be. So you have to figure out what's sending messages and where. I believe the MGI framework has some tools for doing that also, for seeing what messages are getting sent where. I'm trying to remember if that's the case.
Okay. Thank you.
Yep. Okay. Well, one more question and then we'll close out here.
So first of all, this is a great presentation and pretty good demo. I use Active Framework every day. I'm very familiar with it. I like coming to these sessions to see if there's anything new that I've missed.
Okay.
Right? One thing that I find with Active Framework is sometimes it's hard to traverse the code. Going through messages, looking at do's, and understanding where these messages are being called. This is kind of a personal question to see, what do you use to kind of keep track of some of those things as you're building an actor, and so you can go back to where you were without having 1,000 windows or 1,000 VI windows open, right?
Yeah. So, I'm not sure I'm going to get you quite away from the 1,000 windows problem.
Yeah,
that's just what happens when these frameworks get complicated, is there's a lot of code, and traversing it is, I think, the skill of using Actor Framework. When I was talking about spending a few months learning what's going on, that is part of it, right? I remember my own experience of working with an actor and opening up the actor core on the one that I was running, and it had nothing in it. And I was trying to figure out what was going on, right? Because again, actor core doesn't have anything in it. It's just a VI that's abstract that's going to process the messages, and it'll only do the messages that are classed underneath it. I think that's sort of the similar answer to what I was giving before. I believe the MGI tooling does help with a lot of that to keep track of where messages are being sent. But if you don't use that, or if you want more control over it, what I have done in the past is I'll build my own little managers that are basically inside of the VI. There's like the receive message. You can override that and add a little logging step. Right? There's a bunch of open source logging tools that are built into LabVIEW that work pretty well, so that every time a message is received, it just writes a string to a file that says what sent it and what received it and what was the action.
Okay.
That's very easy to do with one VI that you override. Right? Having a window that's up on the side that in one of your actors in your stack can be an actor manager that logs when an actor launched, and maybe you can process what messages it's processing, and you can see maybe what the parent is. Again, these are just strings that you can put out somewhere. And if you put them in the inheritance hierarchy, they're not that hard to do, because everything in your hierarchy is going to inherit ultimately from that actor. So if you start with the NI actor, you build your actor manager that has a couple of the behaviors you want every actor in your system to perform, to make sure that it's logging to places that you can see and that it's showing up places that you can keep track of. That goes a long way to understanding what's going on. And again, it's that little bit of work up front that helps you much later when you're trying to figure out where that message came from or why this thing keeps hiccuping when it should be talking to hardware.
Thank you. I'll try that out. That'll help with troubleshooting actors that are just failing silently.
Yeah. You're feeling the pain that everyone who works with Actor Framework feels. So I wouldn't say you're doing the wrong thing. You're doing it right.
Thank you.
Yeah, no problem. Okay. So just to close out over here, I have a couple of resources that you might want to keep track of. The first is this code that I was showing is all available on GitHub. This presentation will be posted online at some point, so you can grab that now. If you don't grab it now, you're welcome to grab it later. I'll kind of hang out on this slide for a second if you want to do that. And while everyone's doing that, I'll let everyone know there's some swag down here, including some Nigel Gacci stickers, which I had printed. So if you want those, and some of my business cards if you need to get in touch with me. If you enjoy this content while you're here, there's some more Actor Framework relevant content happening at NI Connect. And I didn't notice this before, but they both appear to be happening in this room. I will not be giving those, but if you like this and want to find out more, these are going to be, I believe the Actor Framework Everywhere is going to assume a little bit more Actor Framework knowledge, but I think a class act is going to be a little bit more basic if that's something you're interested in. For the person that was asking about locking loops, that class act presentation on Thursday is probably a good one to attend. There is an active Discord community for Actor Framework. So if you want to participate in that, that's another place to jump on and ask questions. I'll leave that up there for a second. And then in general, if you're enjoying the more advanced LabVIEW content at NI Connect, GDevCon is something you might be interested in. I believe there's a table out there. It's a community of more advanced LabVIEW developers that get together in regional events across the globe, actually. So there's some information on that here if you are interested. And that is it.
Thank you.
Yeah, that's it. Thank you very much, everyone, for coming.